Hi, welcome to the section 4.4 notes. This is on using corresponding parts of congruent triangles. So the first thing we're going to mention is CPCTC. So that is an abbreviation for, we're going to write it out. It's called a corresponding parts of congruent triangles are congruent. So it's kind of a mouthful. And that's why we use that abbreviation CPCTC a lot instead of writing that all the way out. But for now, let's write it out. So corresponding parts of doesn't really get a fancy letter there, but we need the of. And now congruent. And then triangles. And then the word are doesn't get a fancy letter either. And now we've got congruent. Okay, so corresponding parts of congruent triangles are congruent. And now we're going to talk about what that means. This is something that's going to be used quite a bit. So, the abbreviation's helpful, but you still need to understand what it means. So I would say every time that you write CPCTC, just be thankful you're not having to write it all the way out, but also say in your mind what it means, to help you remember that, and you could be asked at some point to have to write what it means. So again, if you say it in your head every time, you would be able to do that if needed. So again, corresponding parts of congruent triangles are congruent. So what that says right underneath the line, it says parts of triangles that are in the same location in a congruent statement are congruent. And we've already talked about that a little bit. We've talked about how the congruent statement tells you a lot of information. We've talked about how the order matters in a congruent statement. So if we look on example 1 here at this particular congruent statement, triangle ABC is congruent to triangle PQR, that one little congruent statement tells us a lot of information. It actually tells us 6 pieces of information of things that are congruent to each other. So it tells us about the angles. We know that A and P are in the first spot, so that means angle A is congruent to angle P. We can see B and Q are in the middle spots, so we know angle B is congruent to angle Q. And we can say C and R are in the last spot, so we know angle C is congruent to angle R. We can also see information about the sides. We know that the first 2 letters are A and B, and the first 2 letters of the other triangle are P and Q. So we know that those line segments are congruent to each other. We can see last two letters are P, C, and Q, R. So we know that they are congruent. And then first and last letter would be AC and PR are congruent. Okay, for example 2, what this one is saying is, it says if D is congruent to G by CPCTC, okay, then what would have to be proved first? And this is kind of how the proofs are going to work. Before we say a set of angles or a set of sides are congruent by CPCTC, we are first going to have to prove the triangle's congruent, and that's what we're going to say here. The triangles must be proved congruent by, and then our choices are side, 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 angle, side, angle, or angle, angle, side, the 4 things that we've talked about. And again, we would say a congruent statement. We would say something like triangle DEF is congruent to triangle GHI. And then by one of these reasons, side, 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 angle, angle, or angle, angle, side. And then we would take a proof one more step from that to say, for instance, angle D is congruent to angle G by CPCTC. Okay. All right, if we look at the first proof here on example 3, again, if they give us some given information, we want to make sure we mark that on the picture first. So it's telling us that AB is parallel to DC. It's also telling us that angle B is congruent to angle D. So I want to get that marked on there, and I'm trying to prove this time that CB is congruent to AD. So this looks different than all the proofs we've done so far in this chapter. The other proofs we've done in section 4.2 and 4.3 have had us proving the 2 triangles congruent by side, 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 angle, side, angle, or angle, angle, side. Okay, in this case, we're not proving two triangles congruent, or it shows that we're proving two sides congruent, but we still have to prove the triangle's congruent. Okay, it just doesn't show that in the proof statement, but we still have to prove the triangle's congruent by side, 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 angle, or angle, angle, side. And then we're just going to go one more step past that and say CB is congruent to AD by CPCTC. Okay, so I kind of already know how the proof's going to end. I just need to get there, just like we've done in 4.2 and 4.3. Okay, so if I look at my picture right now and think, what do I know besides what is marked? One of the things I know is they gave me the fact that A, B, and C, D are parallel for a reason. And I have to think about what I know from that. And I know if these two lines are parallel, then I know that these two angles are alternate interior angles that must also be congruent. Again, in between the parallel line and transversal, in between the parallel line and transversal must be congruent. So I need to say that. I can say angle BAC is congruent to angle DCA. And just like we did in chapter 3, we can say if lines parallel, then alternate interior angles congruent. Okay. I want to look at the picture and think, what else do I know is congruent besides what is marked? And in this case, I can see that both triangles share this side AC. So I can say AC is congruent to AC, and that's a reflexive property. Okay. And then now look at your picture and think, can I say the triangles are congruent now? Yes, I can. Again, those parallel markings do not mean congruent, so don't get confused by that. Those little stars don't mean congruent. That just means where we're trying to get to by the end. So I'm really just looking at my blue angles, my red angles, and my purple side marking to determine that. So I'm going to go and say my triangles are congruent. This time it's not written for me in the proof statement, so I really have to be careful that my right corresponding angles match up. Again, it doesn't matter how I label the first triangle. I can say ACD, but it will matter how I name the second triangle, because if I did ACD, I went no mark, 2 mark, 1 mark. I need to follow the same pattern with the other triangle. No mark, 2 mark, 1 mark would be CAB. Okay, and again, I have to think, why are those two triangles congruent? Again, if it helps to block out one of the pictures, you can, and you can see it's angle, angle, side. Okay, again, sometimes people accidentally put side, angle, angle at first, but you need to write it as angle, angle, side. Okay, now we can go one step past that. Once we say the two triangles are congruent, we've basically said 3 sets of things are congruent for the two triangles. But those, now that we've said the triangles are congruent, those other 3 sets of things must also be congruent as well. And that's basically what we're doing here. Once we've said the triangles are congruent, we can now say any of those other 3 sets of things must also be congruent. And in this case, it's CB is congruent to AD. And we can say they're congruent by CPCTC. Again, every time we write CPCTC, we're going to say it in our head what that means. Corresponding parts of congruent triangles are congruent, just to make sure we have that down. All right, next proof is example 4. And on this one, it is telling us that AB is parallel to ED. So I want to mark that in my picture. It's also telling me that C is the midpoint of BE. So I have to think what that means. What does the word midpoint mean? I think of the word middle. So I know C is right smack dab in the middle between B and E. So that is telling me that this piece is congruent to this piece. Now here's something you need to be careful of. Sometimes people automatically assume then that C is the midpoint of AD, but if it does not specifically state that, we can't assume it. And even if it kind of looks like it is, we cannot assume that. All right, we are trying to prove that AB is congruent to DE. So I'm just putting little stars there to kind of remind me where I'm headed. So to start my proof, I need to say something, a set of congruent things that I know to be true. So I decided to go and start with the parallel lines. I said, okay, if these two lines are parallel, I know that these alternate interior angles must be congruent. So I said angle BAC is congruent to angle CD. BAC is congruent to, I'm looking at the wrong thing, CDE. BAC, yeah, CDE. I'm going to call it EDC. Sorry for the delay. All right, I was looking at the wrong thing. So my reason's going to be if lines parallel, then alternate interior angles are congruent. Okay, here's the other thing. There's another pair of alternate interior angles that you could state as well. So again, you don't have to, but you can. If you want to go ahead and say those are congruent, then I could say angle, in this case, I could say angle ABC is congruent to angle DEC. Okay, so I went ahead and said both pairs of alternate interior angles congruent. And then at this point, oh, I forgot to put one other thing in the proof. A minute ago, I marked on the proof that BC is congruent to CE since I knew C was the midpoint, but I do need to state that in my proof as well. You don't want to forget about that. So I've got BC is congruent to EC, and that's by definition a midpoint. Okay, and again, lines 2 and lines 3 could have been switched. You know, it doesn't really matter which one I do first in that case. Now I can go ahead and say the two triangles are congruent to each other. I can say triangle ABC is congruent to triangle DEC. Okay, think about why. Look at your picture. Don't look at the parallel marks, but if I look at the other information, I've got two angles and one side, and the side is not right in between the two angles. So I can say angle, angle, side. And then now I can take it one step further to prove what I'm trying to prove, and that's that AB is congruent to DE, and that is by CPCTC. Again, corresponding parts of congruent triangles are congruent. Now, you might be thinking, well, why didn't she use the vertical angles? She could have used vertical angles, and that is true. You could also have used vertical angles in there, and that would have been fine. And had you chosen to use the vertical angles, then you could have proven the triangles congruent by angle, side, angle instead. Okay, so I'm going to put a little note down here saying that. Just saying that I could have used angle ACB is congruent to angle DCE. And again, I could have said vertical angles theorem. And then I could have proven the two triangles congruent in this case by angle, side, angle. Would have been an option there. Okay, so again, that would just be a different way to do the proof. If I used the vertical angles theorem, I would have still had to use at least one of the alternate interior angles, but I wouldn't have to necessarily do both of them. Okay, so again, just to remind you that there can be some variation in the proofs. All right, last proof here is example 5. And on example 5, it tells me that AD is congruent to DC, so I'm going to go ahead and mark that. It also tells me B is the midpoint of AC. So if I know, again, that B is right in the middle of A and C, then I know that these two pieces are congruent, but I also need to say that in my proof. I'm trying to prove that ADB is congruent to CDB. So that's what I'm trying to get to by the end. You can see the given stuff was already put in the proof for you. Since it told me B is the midpoint and I know B is right in the middle, and I marked on there that those two pieces are congruent, I need to say that in my proof, that AB is congruent to CB. And that is by definition of midpoint. Okay. From there, I have to look at the picture and think, okay, what else do I know is congruent besides what is marked? And I do know this side they share is congruent for both. So DB is congruent to DB, and that is the reflexive property. Okay. And then now I can say that triangle, I can now say the two triangles are congruent. I can say triangle ADB is congruent to triangle CDB, and that is by side, side, side. And now I'm just taking that one extra step further. Once I've said the two triangles are congruent, I can now say these other two pieces here and here must be congruent. So I can say angle ADB is congruent to angle CDB, and that is by CPCTC. All right, so again, let me know if you have any questions. Again, the more practice you get with these proofs, the easier they will become. And on this section 4.4 homework, you'll have 3 proofs to practice with that. Again, keep in mind with this particular proof, the order of these 2 lines could have been reversed. You could have had flipped line 2 and line 3, and the proof would have still been fine. You just need to end it the same way. All right, have a good day.